Hi everyone, Kleena here, and today I'm going to be taking you through the solution to question 4 from this Leaving Cert higher level exam paper. This question is worth 30 marks and it's based on logs and indices, so let's get right into it. So question A tells us that a sequence is defined as follows. So U1, which is the first term, is 2. U2, which is the second term, is 64. And then it tells us that UN plus 1 is equal to the root of UN divided by UN minus 1. Now, that mightn't make much sense straight away, but we're going to go through that now in this question. So we are asked to write U3 in the form 2 to the power of P, where P is a real number. So we're going to use this formula here. We aren't given U3 here, obviously, so that's what we're trying to find. We can write UN plus 1 as U2 plus 1 here, which is U3. So n is 2 here. Okay, does that make sense? So U3 is equal to the square root of U of n, and we know that n is 2. So UN, so I'll put that there for a second and we'll fill it out, divided by UN minus 1. So n is 2, minus 1 is U1. Now we have U3 is equal to the square root of U2, which we know is 64, divided by U1, which is 2. So U3 is equal to the square root of 32. Now we know what U3 is, but we know that it must be written in the form 2 to the power of P. So how are we going to do this? If you have the number 32 here, we realize that 32, that can be written as 2 to the power of 5. Now, if this doesn't come straight off the top of your head, see what you can work out. So if you go 2 to the power of 1, that's just 2. 2 to the power of 2, that's 4. 2 to the power of 3, and so on. And then when you get to 2 to the power of 5, you'll realize that that is 32. So work up with your 2 to the powers of, okay, until you get to the number you want. Now we know that U3 is equal to the square root of 2 to the power of 5. So we're one step closer to where we need to be, 2 to the power of P. Now we just need to get rid of this square root, okay? So how are we going to do that? We can write the square root of 2 to the power of 5. So the square root of something, so let's say the square root of A is equal to A to the power of 1 over 2. And that is in your log tables if you want to refer to your logs and indices rules for this question, okay? U to the power of 3 is equal to 2 to the power of 5 to the power of a half. And when you have a power to the power, you multiply them. And this is another rule in the logs and indices book. So what you're going to want to do is 5 multiplied by a half, U3, the third term, is equal to 2 to the power of 5 over 2. And this is our final answer. So that is, P is 5 over 2, and that is a real number. Okay, so U3 is equal to 2 to the power of 5 over 2. And for this question, you're going to get 10 marks. So now let's move on to question B. So in question B, we're told that the first 3 terms of an arithmetic sequence are as follows, where k is an element of the real number line. So we're given 5e to the power of minus k, 13, and 5e to the k. So now, when we're talking about arithmetic sequences, okay, we're talking about sequences that look something like 2, 4, 6, 8, 10, and so on, when the difference is the same. So there's plus 2 between all of these. So the first question tells us, by letting y be e to the power of k in this arithmetic sequence, show that 5y squared minus 26y plus 5 is equal to 0. So a very important part about this question here is the arithmetic sequence. So that is going to help us to get this equation. First of all, we're going to replace e to the power of k by y. I'm going to leave off this first term for a second because that's just the most difficult to work out. 13 is just 13 because there's no e to the power of k there. And then 5 multiplied by e to the power of k just turns into 5y. If y is equal to e to the power of k, how are we going to get e to the power of minus k? To go from e to the power of k to e to the power of minus k, you're going to put it to the power, because then, as we did in the previous question, you multiply k by minus 1 and you get e to the power of minus k. So how do we do that? We must also multiply y to the power of minus 1. So y to the power of minus 1 is equal to e to the power of minus k. So I'm just going to box that off there because it's not necessarily part of the question, okay? So 5 to the power of, or 5 multiplied by e to the minus k is 5y to the power of minus 1. Now, how do we find this? if it's an arithmetic sequence, as I just went through, right, the common difference is going to be the same. So the difference between the second term and the first term is going to be the same as the difference between the third term and the second term, and the fourth term and the third term, and so on and so forth. 13 minus 5y to the power of minus 1 is going to be the same as 5y minus 13, if that makes sense. So to write it out properly first, we know that this is T1, first term, this is T2, second term, and this is T3, third term. T2 minus T1 is going to be the same as T3 minus T2. So T2 is 13 minus T1, which is 5y to the power of minus 1. To make this a bit easier for me personally, if I have y to the power of minus 1 or anything to the power of minus 1, y to the power of minus 1 is the same as 1 over y. So that's just a general rule that you can do. So I'm going to write this as 5 over y, just to make it easier as we go forward. So that's the same as T3, which is 5y, minus T2, which is 13. Now, we have a fraction here, so we want to get rid of that. So how do we do that? We multiply across by y, okay, to eliminate this y here. So we're going to have, I'm just going to go forward this way. So 13 by y minus y times 5 over y is equal to y times 5y minus 13y. So now when we multiply in, we have 13y. We're going to have y on top here and on the bottom when we multiply it in. So they can cancel and we're left with minus 5 is equal to y multiplied by 5y is 5y squared and then minus 13y. So now we kind of have what we're looking for. We just need to clean it up a small bit. We're looking for this. We have 5y and that is positive, which is the same here. So we're going to move everything over to the right hand side. We have 5y squared. Now we have minus 13y here. If we move this over to the right hand side, it's going to change sign and become minus 13y. We're going to have minus 26y on the right hand side as well, which is exactly what we're looking for. And if we bring over this minus 5 to the right hand side, it's going to change sign and become plus 5. And we can let that equal to 0. So we have now proved that this equation basically exists when you let y equal to e to the power of k. So I'm just going to draw a neat box around that. And for this question, you are going to get 10 marks. So now let's move on to the last part of question B. So part 2 of question B asks us to use the equation in y in part B1 to find two possible values of k and give each value in the form lnp or minus lnp, where p is a natural number. The first thing that we're going to do is we're going to find the equation in y from part bi, okay, and that's the one we just found, but we were also given at the start of the question. So that is 5y squared minus 26y plus 5 is equal to 0. We're asked to find two possible values of k. So what we're going to want to do is find two possible values of y, because that's going to be obviously the easiest thing to do here. We can use this as a quadratic. So then what we need to remember at the end of this question, once we found values for y, that y is e to the power of k. So now let's start doing this as a quadratic. 5 multiplied by 5 is 25. What are two factors of 25 that are going to make up minus 26? So that is minus 25 multiplied by minus 1. So now 5y squared minus 25y minus 1y. I know there's a different way of doing quadratics, so whichever way you're most comfortable with to find the two values for y. Plus 5 is equal to 0. So here we're going to take out 5y. We're left with y minus 5. And then here we're going to take out minus 1. And we're left with y minus 5 is equal to 0. So now we have 5y minus 1 multiplied by y minus 5 is equal to 0. So 5y minus 1 is equal to 0. And y minus 5 is equal to 0, just from the two brackets here. So 5y is equal to 1. Y is equal to 1 divided by 5, or 1/5. And here it's a bit simpler. You just move the 5 over here and it becomes positive 5. So y is equal to 5. So I'm just going to mark those. Now, we found two possible values of y. Now we need to use this to find two possible values of k. Y is equal to ek, e to the power of k. We can replace y here with e to the power of k. So e to the power of k is equal to 1 over 5. E to the power of k is equal to 5. Now, it gives us a hint here when it tells us that it needs to be in the form lnp. So we know we need to use our ln. Let's bring the k down here. K by ln e, okay, and ln e is always going to be 1, is equal to, you have to put the ln on the other side as well, ln of 1/5. And then here, bring the k down, k ln e is equal to ln of 5. I'm just going to bring down the page. So here we are left with the answer. So we have k is equal to ln of 5. And that is a perfect answer because it's in the form ln of a natural number. Here we're left with k is equal to ln of 1 over 5. While this is correct, it's not in the right form because they want it in k is equal to ln of a natural number, and 1 over 5 is not a natural number. So how can we rewrite this? We can rewrite 1 over 5 as 5 to the power of minus 1. And you can check this in your calculator, right? 5 to the power of minus 1 is 1/5. ln of 1/5 is the same as ln of 5 to the power of minus 1. And now when you have this, you can bring the minus 1 down in front of the ln. So we're left with k is equal to minus ln of 5. So that's our answer. Let me just make sure that this is an acceptable answer. So yeah, you can leave it in the form lnp or minus lnp. So we have found it in 1 lnp, which is ln of 5, and 1 which is minus lnp, which is minus ln 5. So just an important thing to note before I finish the video, you should always take note of what it wants p to be. So if it was p is an element of the real numbers here, then you could have left it as k is equal to ln of 1 over 5. But because it specifically says that p is a natural number, if you left it like that, you probably would lose a mark or two in this question. Okay, so make sure you always read the question fully. So for this question, you're going to get a total of 10 marks. So that's all for this video, guys. I hope you found this video helpful and that it might have cleared up any issues that you had. So thanks very much for listening, and I'll see you all in the next video.